Let's talk about the key activities within data governance and data management. I want to really illustrate what each one of these disciplines does, because you may know the difference on a conceptual level, but you may ask, hey, data profiling, is that management or is that governance? Or setting policies, is that management or is that governance? So I want to give you some examples of the usual activities within each one of these two disciplines. Let's take a look at some examples. In order to better establish the distinction between the data management and the data governance practice, let's just cover some of the key activities within each, because this will emphasize the distinction. In specific, 3 examples of data management activities and 3 examples of data governance ones. First, we'll talk a little bit about data profiling, that is, the process of examining and assessing the quality of specific data. Then, we'll talk about data dimension definition. That is, data quality is not universal. Data may be of high quality according to one dimension and low quality according to another one. So this is exploring the angle, if you will, through which data quality is analyzed. Then, still within data management, we'll cover remediation. That is, the process of actually fixing and correcting low quality data. Then, within data governance, we'll cover first data requirements and expectations. That is, in order for data to be of high quality, what are the value ranges and what are the formats expected of those data? Then, defining policies, which include standards and controls for data. What is required in terms of processes to maintain high quality data? And finally, within data governance, we'll cover process controls and audits. That is, verifying independently whether the processes that we use and the controls for data quality are working or not at all. Let's start with data profiling. This is a type of assessment activity that analyzes the level of data quality in a specific database or medium which may not be a database, such as a text file or other types of data storage. This is usually the first activity in terms of data management, and it's the one that reveals the data problems. It's usually followed by remediation of the data that has the problem. As the name says, profiling has to do with profiling the data. So we take a quick look and we label it as being of high quality, of low quality, and in which ways. It's important to notice that data profiling is done according to what we call data dimensions, usually one specific dimension at a time. We will cover dimensions in much more detail later, but for example, one dimension is completeness. That is, how much data are we missing in this database or table or whatever it is. Other important dimensions, which we'll also cover, include, for example, currency or timeliness. That is, are these data still relevant? If you have customer data from 2 years ago, the data themselves may have the right values and they may be complete, but they are not up to date. Or, for example, consistency. That is, if you have the same data across different data sources, are these values the same across the different containers? Then, data remediation is the actual process of changing data to increase its quality. This usually consists of processes such as parsing the data, cleansing the values which don't make sense, and then standardizing the data under one format, or also possibly by adding new information that increases the quality of these data, which is known as data enhancement. Onwards to the data governance side. First, data governance sets policies. That is, it sets processes that have requirements embedded in terms of acquiring, using, storing, transmitting, or doing anything else with data. For example, a data requirements policy when creating data could be something like, for any customer, customer address data entered by hand in this application must contain a valid United States zip code and a street number. That's an example of a policy. Or personally identifiable information that is not used must be purged within 24 hours. That's another policy. In specific, the most common type of policy are standards. And many people may know this, but standards are simply policies that define a specific format of exchange. In other words, you use standards when the information is expected to be shared. For example, currencies, temperatures, product taxonomies, and others are all standards. They're important to share information. In the case of temperature, for example, it doesn't really matter what units you use when storing temperature readings for internal use. But if you want to cross-reference those data with external providers or just share the data, you could standardize it, for example, in Celsius or Fahrenheit formats. As we mentioned, an example of a policy in this case for data entry is saying customer addresses must always be inserted, containing a full postcode in a 6-digit format. This is for data entry. You could have a policy for data deletion as well, such as saying personally identifiable information, or PII, must not be retained after the retention period is over, and it must be securely deleted. You can have dozens or even hundreds of policies for different departments, for different information stages, and with different requirements. It's important to notice that data governance policies are usually derived from the expectations that you have in terms of the data. And usually, data management is the one that provides the feedback for this, usually from data profiling, which tells you about the rules for data to be valid. For example, if during data profiling you realize that the temperature values of a database field are always between 0 and 100, you're more likely to create a requirement that states new temperature records must have the temperature field always as a number from 0 to 100, and a policy for data entry that represents it. Then we have controls and audits, and these are simply independent activities that verify how actual operations comply with the policies. For example, you have a requirement of the temperature always being between 0 and 100, but you will never know if the data are actually obeying that unless you perform some kind of check. These can be done with automated tools or manually by someone. Both are very useful. But at the end of the day, some kind of audit has to occur to keep the information honest, if you will. Let me give you an example. In banks, one type of regulation, which is very strict, is AML, or anti-money laundering regulation. It demands that the banks keep records of suspicious activity and store them for long periods of time in case legal actions are created, and the bank must help with documentation. Another type of report, which we'll focus on in this example, are the CTRs, or currency transaction reports. And these are reports that must be filed for every single transaction above $10,000, regardless of origin and regardless of destination. So we would have the following. Data profiling is the first stage. The data management team goes in and asks how many transactions are missing CTRs. It's profiling that dataset. The data dimension in specific here is completeness. That is, how many values are actually missing. Then we may have data remediation after the results of profiling. That is, we add currency transaction reports to inexistent transactions. We go in and we add the data. Then it's about defining the data requirements or expectations. That is, every transaction entity instance in the database with over $10,000 in the value field must have an associated existing instance of the CTR entity associated. In a relational database, such as SQL, maybe it's a foreign key to a valid record. Or in human language, every transaction above 10,000 needs a corresponding report in a one-to-one relationship. Then, the policy or standard. Every new transaction above $10,000 in the future that is processed must have an associated CTR when processed, otherwise a flag is raised. And then the data controls and audits can be the following. You can have an automatic mechanism that scans the database periodically, or even an SQL trigger, if it's a relational database, that immediately alerts someone if there's a new transaction record above $10,000 in that field and with no CTR in real time. But you can also have independent human audits of bank transactions. That is, someone goes in, takes a sample of transactions and checks whether the reports are there or not. Or let's take a physics research project where temperature readings are being saved. We start with data profiling. That is, we go in and we ask how many of these readings are realistic. Are there errors? The data dimension is accuracy. That is, do the values that are present actually make sense? We know the values are there, but are they realistic? Then, data remediation. We can find alternate sensor readings for values that just don't make sense in case we have a secondary data source, for example, and we can replace them or average them or even remove them. For example, a value of minus 100 if there's an error. We'll take a look at this later, but the outlier values don't need to be deleted. They may mean something. For example, a minus 100 temperature can actually be valid and it can be a system error. Then, the data requirements and expectations. For example, mandating that every temperature reading in the future must be, the field in specific, an integer between 0 and 100. Then, we can have a formal data policy or standard based on that rule. That is, every temperature reading that is inserted into this database must have a valid value of 0 to 100 Fahrenheit. And finally, we can have several controls or audits. First, we can have automatic alerts on temperature values that are not realistic. In other words, if a temperature value is higher than 100 or lower than 0 and that is submitted, an immediate alarm is broadcast. Or even if there is a sudden change, such as, for example, the last 10 readings all having been 20 degrees and the last reading is now 60 degrees, can also be implemented, because this can indicate sensor malfunction or even a serious situation like an actual fire or imminent explosion. And then we can have a periodic human inspection of the sensors themselves, which are submitting the data or the data stored in them, or both. What are some examples here? The first is that all operations revolve around data quality. Both the data management and data governance disciplines revolve around improving data quality. Data management aims to directly increase it in the short term with fixes, and data governance aims to indirectly improve it in the long term. Then, there is more to it than fixing. We are talking about finding a data quality problem and immediately remediating it, which does occur, but we'll later talk about the fact that there are other actions that we can take, not just remediation. For example, one of them is finding the root cause of the issue. That is, if you find data with errors in a report after 10 transformations, even if you fix them there, they're still wrong everywhere else. You have to find the root cause. And another option is to set up monitoring and alerts in order to detect new problems. And finally, SQL triggers in relational databases are very popular monitoring tools. Although they're not feasible for all types of fields, SQL triggers can be very useful automated tools. For example, for number values. This is because they can instantly detect records that are inserted which do not obey the conditions and trigger an alert. In our example, if a record with a temperature reading with a value below 0 is inserted, a trigger can immediately alert the data stewards. What are our key takeaways this time? The first is data profiling. It's the name given to the activity of analyzing and assessing specific data sets in order to determine the quality of the data within them, and with them, any possible issues. Then, data dimensions. Data can be of high or low quality depending on the dimension selected. In fact, it can simultaneously be of very high quality in one dimension and very low quality in another one. There are many dimensions. The completeness one, for example, measures how much data are missing. Currency or timeliness measures how up-to-date the data are. Accuracy measures whether the values make sense, and so on. There are other important dimensions. Then, data remediation. This is the name given to the process of quote-unquote fixing the low-quality data through a process, which either replaces the data, usually by parsing, cleansing, and standardizing, or eliminating outlier values, or by adding more detail to the data, known as data enhancement. Then we have data requirements and expectations. Feedback, usually from data profiling efforts or due to the efforts of data stewards, possibly, usually informs us of what the value ranges are or what the formats are for data, or what they should be. These are then formally defined as the requirements for the data. They must be in this format and they must have this range of values for every field, in every table, in every database, or the equivalent for other types of storage. Then we have policies and standards. Policies are the actual processes of a firm that state the data must do this or that when acquired, when used, when stored, transmitted, or any other. Standards, in particular, are policies for data that are meant to be exchanged. And finally, we have audits and controls. While operations will tend to obey policies and standards, it's still crucial to verify, especially if regulatory compliance depends on them. So, on one hand, controls alert of policy breaches, while audits independently verify compliance with those policies. So as we see, the operations that directly deal with data, such as profiling data, remediating data, are all within data management, while the operations that deal with setting the policies, setting the validity rules, and other indirect things that don't actually manage data, but guide the management of it, are all data governance. And don't forget that within a remediation process, we may have operations from data management and data governance that intersect with different levels of intensity.